So we are discussing about Carter giants. So in that we have seen the introduction about these Carter giants in the previous class. Also we started discussing about the design procedure for a socket and spigot joint. So today we'll finish that. So in that first we discussed the first parameter you need to calculate it is diameter of the rod. First by considering the failure of the rod in tension, you can find out the diameter of the rod, which is denoted by small d. So for that, you need to consider what is the tensile strength of the rod. Tensile strength of the rod or shearing strength of the rod is given by 5/4 into d square into sigma t. If we equate this one to the given load or applied load, you will get the diameter of d. That is the diameter of the rod. So once you got this d, then you need to calculate what is the D2 value just by considering failure of the spigot across the weakest section, that is across the slot, wherever you have a slot. So at that point you need to consider, and the tearing failure, there also the failure is tearing failure, that is the tensile failure only. So for that again you need to consider what is the tensile strength of this spigot at this weakest section. So for that we need to calculate what is the area of this section. So that is nothing but 5/4 d2 square minus d2 into t multiplied by sigma t. You will give the tensile strength across the section, and you need to equate that one to the applied force P. Then from that equation you will get your d2 value. But like I said here, you have two unknowns here in this equation. d2 is unknown and t is also unknown. So generally the relation between d2 and t, so empirical relations are there. We'll use those empirical relations to find the parameters. So that means we'll take this t as d2 by 4. Empirical relation what we need to use here is, you have to consider your t, thickness of the cotton is equal to d2 by 4. So now if I use this empirical relation, then in this equation there is only one unknown, so that is d2. So using this equation now we can calculate d2 value. So what is the d2? That is the outside diameter of this spigot. Once you got that, so this outside diameter of the spigot is nothing but it is same as the inside diameter of the socket. So we need to compute what is the outside diameter of the socket. So that we'll see in the next one. So okay, so before going to that, once you find out the d2 value, then you need to check for the crushing strength of this spigot, whether with the determined values of d2 and t, this is going to withstand that crushing strength or not, or crushing stress or not. So for that, first we'll compute what is sigma c value. So then we'll compare the sigma c with respect to the allowable sigma c value. So if this sigma c is less than that allowable sigma c, then our design is safe. We can proceed further. Otherwise, we need to modify the d2 again. So this is the formula to compute the crushing stress in this spigot, where the cutter and the spigot are having an interface. So that is nothing but P by d2 into t. So we know P value, d2 and t we already calculated. Then we can compute the sigma c. So using this equation, we need to compare that induced crushing stress to allowable stress. If the allowable stress is more than the sigma c, then your design is safe. That means whatever values you got for d2 and dt, you can fix those values. Otherwise, you need to modify this d2 value according to this equation now. So in place of the sigma c, you have to take sigma allowable, or sigma allowable is nothing but p by d2 into t. From that, we can calculate d2 value. Okay, so that is about finding out the outside diameter of this spigot. Then we'll come to the inside diameter of the socket. So again, here also we'll consider the tensile failure or tearing failure. So here you have two diameters. Inside diameter we already calculated. This diameter is d2. We already done it now. So that is nothing but this is same as your outside diameter of the spigot end. So now we need to compute this d1 outside diameter. What is d1? So again you have to consider this is the failure section. So in this failure section, you have to consider what is the tensile strength of this failure section. That is nothing but area divided by the tensile strength of this material. So area is nothing but here you can see that here it looks like a hollow circular cross section. So for a hollow circular cross section, we know the formula, that is 5 by 4 into d1 square minus d2 square. But since you have a rectangular hole throughout this section, you have to subtract the area of that rectangular hole. Area of that rectangular hole is d1 minus d2 into t. So now this is going to be the area which is resisting the tearing failure of the socket across this slot. So now if you equate this one, this tearing strength of the socket across the slot to the applied force. So from the free body diagram, we see that here at this location only there is a force of P is acting. So then if you equate that, you will get an equation that is going to be the equation which you can use to determine what is the value of D1. D1 is the outside diameter of the socket. So now in this equation you can see that everything is known except D1 only. So you can use this equation to find out this D1. So from this equation, outside diameter of the socket D1 may be calculated. So I think up to this point we already discussed in the previous class. So now we'll move further. So we'll try to consider or try to determine what is the dimensions of the cutter itself. So we already calculated the thickness T. T is we taken it as D2 by 4 just by considering the tearing strength of the spigot across the slot. So there you have the expression for T. We have taken T is D2 by 4. Already calculated T. Then what I need to calculate is I need to calculate what is the mean width of the cutter. So the mean width of the cutter is determined based on the shear failure of cutter. See, you can see it here. I already shown to you the free body diagram of the cutter earlier. So if I go back to that, yes, this one. See here, it is this here you have a P by 2 is acting like this, and this force P is acting like this. Then what happens is this portion of this cutter will slide in this direction. So therefore, because of that, you are going to get a shearing failure. Because it is a sliding, we'll call it as a shearing failure, not tearing failure. So for that, I have shown the free body diagram also here. Okay, you can see that here, because of you have P by 2 acting here, P by 2 is acting here, and P is acting here. So this P is pulling this portion in the rightward direction, and this P by 2 and this P by 2 is pushing this top and bottom in this direction. So therefore the shearing will going to be take place something like this. So now if I take the shearing section here, it is going to be something like this. So here it is B and thickness is T. So and also you can clearly see that here the cutter is in double shear, not in a single shear. It is shearing at this location as well as at this location. So this kind of shear failure, what we will call it as a double shear. If it is shearing off only at one location, we call it as a single shear. It is shearing off at two locations, then we call it as a double shear. Then shearing area multiplied by the shearing strength will give you the total load, and the total load you need to equate it to the applied load. Here the applied load is again P only. So this P divided by shear area. What is the shear area? So this is B and this is T. Area of this rectangle is B into T, but since I have a double shear, I need to take the area as 2 into B into T multiplied by the allowable shear stress. Tau will give you the shearing load carrying capacity of this cutter. So it should be equal to your applied load. Applied load is P. So from this, we can calculate the B value. That B is nothing but the mean width of the cutter. So that's what I showed it here. Since the cutter is in double shear, therefore shearing area of the cutter is nothing but 2 into B into T. Then the shearing strength of the cutter is given nothing but 2BT multiplied by the allowable shear stress. So from that we can get the equilibrium equation, that is load is nothing but shear load is nothing but 2 into B into T into tau. From that you can calculate the dimension B. So that means now for the cutter we know T, we know B. Only thing what you need to find out is L, the third dimension, L. So we want to calculate the L value. We'll use the empirical relation for because there is no failure criteria to determine this L value. So what we'll do is we'll use the empirical relations to find out this L value. Okay. So then next, okay. So maybe this point actually we need to check earlier, but again anyway. So we are doing it here. So we already calculated the diameters D2 and D1. So here, okay, sorry, here it is a collar, not that slot. Failure of socket collar in the crushing. So collar is something like this. This is the collar here. We need to consider what is a crushing failure. So why it is crushing failure? Because you are inserting a cutter here. There is a rubbing action between this collar and this cutter. So to avoid that failure, the bearing stress or compressive stress is going to be the criteria for that. So the crushing stress or bearing stress we have to use to find out the failure criteria for this socket collar. So for that, here the area, so that means the contact area you have to take. So the contact area is going to be only D4 minus D2 into T. Why it is D4 minus D2 into T only? Of course, the thickness of the cutter is only T, so that is the area which is in contact with this collar. But why it is D4 minus D2? Here you can see that inside diameter, it has two dimensions, outside diameter as well as inside diameter. So here you have to take only this portion. So this portion there is a hole is there. So that means if there is a hole, it cannot, the material cannot be contact with each other. So because here there is no material at all. So therefore D2 you have to subtract. So if entire thing is a solid one without hole, then you have to take D4 into T. So that means D4 is this is the diameter, outside diameter of this collar multiplied by T. But in that portion here you have a rectangular slot is there, so you need to remove that area. So that area is D2 into T. If I remove that area, then D4 into T minus D2 into T is going to be the area which is resisting the crushing of the socket collar. So multiplied by this resisting area multiplied by the crushing strength, that is sigma C, you will get the crushing strength of the socket collar, and you need to equate that one to the again to the applied load. The applied load here is again it is P only. So from this you will get your D4 dimension. D4 can be determined using this relation because we already determined D2 and DT. So using this relation we can find out D4 value. Then failure of socket end in shear. Failure of socket end in shear. This is the end of the socket. So earlier we have seen the crushing failure. Now we can see that the shearing failure. So there may be a possibility of the socket end. This is what we call it as a socket end or collar. So which is going to fail in shear. So we can clearly see that only this portion of the socket collar is coming out of the socket. So therefore this kind of failure what we will call it as a shear. And also you can observe here the shear is a double shear here. Shear is double shear, and you have to consider what is the area of that shear. So now if I take this section here, this is going to be the section of that portion. So here the inside diameter is D2, outside diameter is D4. Then this dimension, the collar width, what you can take is collar width, we are taking it as C. So therefore the area is going to be D4 minus D2 into C. So that's what we are taken here. D4 minus D2 into C is going to be the area of the collar. Since it is in double shear, you have to multiply this one by 2. Since the socket end is in double shear, therefore area that resists the shearing of socket collar is 2 into D4 minus D2 into C. So this should be equal to your applied load. Applied load is again P. So from that you can calculate what you can do is you can calculate the parameter C. So that means the width of the socket collar you can determine. So for that the equation is 2 into D4 minus D2 into C into tau, and it should be equal to your applied load P. So from that, okay, so instead of width he is calling it as a thickness of the socket collar C will be determined by considering the shearing failure of that socket end. Okay, once I got the C value, then we'll move on to, okay, so here failure of rod end. So that means you need to calculate what is the A value also. So that is how much portion I need to kept beyond the cutter. That we'll call it as A. So this A dimension is calculated based on failure of this rod end in shear. So for that again you can clearly see that here it is in double shear. The area of the shearing area is nothing but this is A, and this diameter is D2. This diameter we already calculated, that is D2. Again here since it is in double shear, our area is going to be 2 times the shearing area, that is 2 into D2 into A, that is going to be the shear area multiplied by the allowable shear stress tau will give you the shearing strength of this rod end, and you need to equate that one to the applied load. Applied load again here also it is P only, so you can see that here it is P. So from that we can calculate what is the C value. So that is the portion which should be there beyond the cutter in the this spigot end. In the spigot, we will call it as we will denote the dimension as A, and that is determined like this. So area is A into D2 multiplied by 2 because it is in double shear. Then this is the shearing strength of the rod end, and then using this equation P is equal to 2A into A into D2 into tau, we can calculate the value of A. So from this equation, the distance from rod end of the slot end to the rod end may be determined. So then failure of spigot collar in crushing. So we already calculated those dimensions here. No need to calculate anything. Just we'll check for the crushing strength. That is the only thing here we need to do. So this is our collar. So collar is having diameter D2 and D3. So then here crushing means, yeah, any doubt?
Previous slide ఒకసారి చూపించండి సార్.
Previous slide. What do you want here? If you want, I can provide these slides to you. No, it's not an issue. So slides I will provide it to you. Maybe at the end of this topic, I will provide these slides to you. Don't bother about this one. You want to note it down something here?
Yes, sir.
Yeah, note it down there.
అయిపోయింది సార్.
Okay. So now failure of socket collar in crushing. So for that we need to calculate what is the crushing area. So this is the area which is in contact with the cutter. So this area is going to be, so you can see that here clearly it is going to be hollow circular cross section. Then cross section area is going to be 5 by 4 into outer diameter is D3 and inner diameter is D2, D3 square minus D2 square. So then that area, crushing area multiplied by the crushing stress will give you the crushing strength. Again, that should be equal to P only. So from this, okay, if we calculate the DT, the D3, that is the outside diameter of the socket collar, we can find out just by considering the crushing strength of this socket collar. Then failure of spigot collar in shearing. So I think we already done this. No, T1 here we need to calculate T1. So what is the T1? You can go back to the diagram. You can see that T1. What is the T1? Thickness of spigot collar. Okay, so if you want to calculate the thickness, then you have to go for, yes, see, you can see it here. This is the thickness. So this thickness will take, or else thickness of this one. This will call it as T1. So this can be determined based on the shear failure only, and also here also the failure is double shear. So then the area is going to be the outside diameter you have to take. So here you don't have any hole here. So outside diameter multiplied by this distance, that is the thickness T1, will get the shearing area. Then if you multiply that one by twice, you will get the shearing area multiplied by the shear stress, will get the total shearing strength. So now I'll go back to that. Yes, it is over. Okay, right. See here, you can see that this is our spigot collar. Okay, so now considering the failure of spigot collar in shear, so the area is going to be only D2 into this thickness. So that D2 into thickness is, okay, maybe here it is a wrong figure I have taken it here. This figure is wrong. So you don't have D2, and here the thickness is T1, not T. Maybe this is the wrong one. So 5 into D2 into T is going to be the area which is in shear, multiplied by tau, you will get the shearing strength of the collar, and then you need to equate that one to the applied load P. So from this you can calculate T1. So once you got the T1, then next thing is Of course. So here we already calculated the dimensions of the kata, but still we'll try to check for bending also. In order to find out the bending stress induced, it is assumed that load on the cutter of the rod is uniformly distributed, while socket end it is varies from 0 at outer end and outer diameter D4 and maximum at the inner diameter D2 as shown in figure. Actually, it is a distributed load and also whether this cutter is going to bend or not. To check that, we need to find out what is the bending stress. So for that, here this is going to be the assumption. So earlier I have shown a free body diagram. Here I have shown the force as only P, a point force P this side, and here this side P by 2 and this side P by 2. But so with this, okay, you can calculate the bending here. So if I treat this one as a simple support, if I take this one as a simply supported beam, some kind of thing like something like this. See here, here this is P by 2. The reaction here it is P by 2. Here also P by 2. So that is these two ends, and somewhere here I am applying a force P. So now you can treat this one as a simply supported beam subjected to some point load. So because of that, the bending moment, if you draw the bending moment diagram, it is going to be something like this. If I take this distance is D by 4, the total distance is D4. Total distance is D4. So then your bending moment is nothing but P into D by 2. P by 2 into D by 2. That is P into D4 by 4. The bending moment diagram will be a triangle here. So this is P by 2, here it is P by 2, then this distance is D2 by 4, D2 by 4. This distance is also D2 by 4. Now at this location the bending moment is nothing but P by 2 into D by 2, that is D4 by 2, P into D4 by 4 is going to be the bending moment. So once I know the bending moment, I can calculate the bending stress, that sigma is equal to M by Z. So while taking that, what we'll do is we'll consider this as a rectangular cross section. We know it is a rectangular cross section. So from the rectangular cross section, we can easily find out, we can check. So B is going to be the width and T is going to be the thickness. But the thing here is the width is not constant. The width is varying because we have a taper on this cutter. So due to the taper, the width is not constant. See here, this side there is no taper, but this side there is a taper. So the width is increasing in the upward direction. So B is not constant here. B is a variable. So one thing is, what you can do is you can approximate that one as a mean width and you can use B and T as the dimensions. Then in that case your B is nothing but, Z is nothing but BT square by 6. For a rectangular cross section modulus Z is given by BT square by 6. So here I know the bending moment M, which is P into D4 by 4, and this is a Z. I can calculate the bending stress. So from that I can check whether it is going to fail in bending or not. So that is one way of doing it. But here what it is, so this is the simplest simplification and simplest analysis. But instead of taking this one as a point load, what he has done is this P by 2 and this P by 2 and this P here, whatever the loads are there, actually they are a distributed load. They are not a point loads, because why you got this P here? Your spigot end is in touch with this cutter this side. So the spigot, whatever reaction of the spigot, the reaction is, total reaction is P, but it is a distributed force. So therefore, that's why he has considered that one as a distributed force here. So the total area, total load here, it is equal to P only, but it is distributed across D2. That is nothing but the outside diameter of the spigot end here. So this side, it is in touch with the collar of your socket. So only this portion, in this portion and in this portion, it is in contact. So therefore, the force is, the reaction is going to be only whenever there is a contact. At that contact location only you have a reaction. So now this reaction force also is assumed as a distributed one. That is considered as a UVL, because here there is no material or nothing is there, no contact surfaces are there in this, so I cannot assume it as a uniform. So therefore you assume it as a UVL, that is uniformly varying load or linearly varying load. So using this also you can draw the bending moment diagram and then you can find out the bending stress also. But only thing is, instead of going for this, even you can use the simple analysis also, you will get the rough estimate whether it is cutter is going to fail in bending or not. For that, Only you can treat these loads as a point loads, draw the bending moment diagram, from that find out bending moment, which nothing but maximum bending moment is P into D4 by 4. Then this is the section modulus, you can calculate the sigma value. Once you got the sigma value, check whether it is within the allowable limit or not. If the bending stress is within the allowable limit, we can ignore that the cartridge is not going to fail in bending. Okay, so that's what he done it, but what he has done it is, here he has taken a complicated relations, and then so he draw the free body diagram, and also bending moment is also considered. So therefore this is going to be the expression for the bending moment. If you consider the loads are a distributed load, so it is going to be somewhat complicated equation. So if we simplify this, we are going to get this one further. Similarly, further simplification we get like this. So then the Z formula we know, that is BD square by TB square. Here why it is TB square, because the bending the B is something like this here. So you have to take the formula in reverse way. TB square by 6 is going to be the section modulus. So from that you can calculate the bending stress. So for that you should use this formula. I think that is there in your data book also. No need to remember all these things, but just I explain the procedure how you get these formulas. So now I think I'll check that whether this bending, I think it would be there. It should be there. I'll verify that whether it is there or not. The cartridge joints, if I go to cartridge joints, you also open our data book, and also you can also check it. So cartridge joints is chapter number 7. So I need to go for chapter number 7. Maybe he has not given that. So in the data book what I have with me, so only he has not given this formula. So suppose if they ask you check for the bending of the carter in the examination, then so instead of going for this complicated one, like already what I told, use the relations to find out the bending stress. So yes, this bending stress induced in the carter should be less than the allowable bending stress of the carter. So that is the criteria what we need to follow for the failure of bending stress. So then the remaining thing, like I already said, the length of the carter, we won't use any failure criteria to find the length of the carter. So generally the length of the carter is taken as L is equal to 4 times the diameter of the rod, 4D. The taper in the carter should be 1 in 24. In case gather taper is required, then locking devices must be provided. So then the draw of the carter is generally taken as 2 to 3 mm. Draw, what is the meaning of the draw? If I take the carter, so the difference between the width, top width and bottom width. So here if I take B1 and this is B2, the difference between these two, we'll call it as a draw of the carter. B1 minus B2 is nothing but the draw of the carter. That can be taken as 2 to 3 mm. So apart from that, you have, when all parts of the joints are made of steel, the following proportions in terms of diameter of the rod D is generally adapted. So these are all the empirical relations for all those things. That is, once you calculate the D value, then your D1, D2, D3, D4, A, C, B, L, T, T1, E, everything is calculated in terms of D only. So you can use these empirical relations to find out that, and taper should be 1 is to 24, or maximum draw can be up to 3 mm. So these are the empirical relations you can use to find the dimensions of the carter. So when you are going for these empirical relations, like already told, so we have to follow the failure criteria only to determine these dimensions. Suppose using the failure criteria, I got a D1 value. Let us say D1 is equal to some 30 mm or 20 mm, I got it. So then after that I am checking for the another failure, let us say crushing failure. If I check for the crushing failure, so now this D1 is not suitable. Whatever 20 mm I got from the failure criteria, this D1 is not satisfying that crushing criteria. So then in that case, I'll use this one. In that case, I'll go for this empirical relation. So once I select the empirical relation, then also I need to check for, with this new dimension of for D1, whether it is satisfying the crushing stress criteria or not. So then only I can say that the design is correct or design is safe. Okay, right. So whatever is there, all these empirical relations, all these things are there in your data book also. Maybe in the previous class I already shown to you. So out of all these things, so he has given the equations also. If you refer our data book, he has given equations A to J. Equation numbers from A to J. He has given all those equations. So what you have to do is you have to properly use those equations accordingly. So in that order only you need to do. So don't bother about in which order you have to calculate, determine all these dimensions. Means you follow the order what he has given in the data book. So generally what they will give you is they will give only p value. They will give you only p value. So, but actual data required for solve this problem is you required p value, you required what is sigma t, what is sigma c, what is tau. Those things are also you required. But sometimes they may give, sometimes they may not be give. So if they are not give, at least you have to take those values from the data book. So in the beginning we said that carter is made of mild steel. So for mild steel, what should be the allowable tensile stress? So or what is the allowable crushing stress? So you have a data book with you. You need to check in the data book for a mild steel what is the tensile strength. You have to take that and from the data book and then you need to take the data. Maybe if in the problem itself, if he has given the data, no issue. So whatever data given in the problem, you have to use only the data. If the data is not given in the problem, then you have to use your data book to identify the properties. So that means only they will give only the applied load P is equal to some 30 kilonewtons or 20 kilonewtons. So then design a, they will ask a question something like this: design a socket and spigot joint, socket and spigot carter joint to carry an axial load of 30 kilonewtons. Simply they will give question something like this. But actually what he has to give in addition to this P, he has to give what is sigma T, what is sigma C, what is tau. These values also you need to give. What is sigma T? Sigma T is nothing but the tensile strength of the rod or allowable tensile stress in the rod. So sigma C is crushing stress in socket and spigot. While you calculating those dimensions, sigma C is corresponding to socket and spigot. Similarly, tau is corresponding to your carter. So that means you need to identify what is the material of the carter and what is the material of socket and spigot. Suppose if all are made of same material, so then for that material you have to identify what are these three values. That is, what is the tensile strength, what is the crushing strength, and what is shearing strength of that particular material. So don't say that this data is not given in the question. It is question is incomplete and are out of syllabus, something like that. So since you are allowed to use data books in the examination, so you cannot say the data is missing. So you have to use the data book and you have to pick the value from the data book, because in the data book this data is available for all the materials. The material properties are available. So then if the rod and carter are made of steel or wrought iron, then these are the problems. So these are the relations also you can take. Only sigma T you can take it from the data book. Then the relation between sigma T and tau is 0.8 times sigma T is equal to your tau, and 2 times sigma T is nothing but your sigma C. You can take, these are the relations, use these relations. Then tensile strength you will get from the data book. So for mild steel or wrought iron, you have a tensile strength properties. So then you can take, these are the values for shear strength and as well as crushing strength. Okay, so with this we come to the end of how you can design the carter joint or the socket and spigot carter joint based on the given axial load. So now coming to the how to use the data book in the examination point of view. So what you do is, like already told, they will give you p value. If sometimes they might not give sigma t value, sigma t, sigma c and tau. Let us, if they given those values, then one thing. If they are not given, then you need to find out what is the sigma t value from the data book. Then use these empirical relations to find tau and sigma c. So that means we know load is given. So of course, if sigma t, sigma c and tau is given, we'll take them as a given data. If not, only load is given, so we have to pick the sigma t value. So then using the sigma t value, we'll find what is tau, what is sigma c. So after that, then in which order I need to solve the problem? That is most of the students will face that kind of question. So don't bother about the order. So whatever the things he has given in the data book, so formulas he has given from A to J. So you follow the same order. So first, what is the first formula? Tensile strength of the solid rod. He has given it as P is equal to 5 by 4 d square into sigma t. That is the first formula A. So using that formula, you calculate what is d, small d. That is the diameter of the rod. So you'll get that. Then next thing, next formula B, tensile strength of spigot through quarter hole. So the formula what he has given is P is equal to 5 by 4 dt square minus d2 into t into sigma t. So in using that, we need to calculate what is d2 value. So we should know what is the relation between d2 and t, then only you can solve that equation. So the relation is d2 is equal to, you can see the data book also, he has given those proportions. So after these formulas, after formula J, usual proportions of socket and spigot quarter joint, there he has given all the proportions. In yesterday's class, I shown you all these things also. Here, they are going to be, in that clearly you can see that T is equal to, what he has given is 0.3 times D. T is equal to 0.3 D, which is same as your d2 by 4 also. If you substitute that empirical relations, you will get T is equal to d2 by 4 only. So now use second equation to solve for d2. Then crushing strength of spigot collar. So use that relation to find out, determine what is d3. Then equation D, shearing strength of spigot collar. P is equal to pi d2 t1 into 6 tau. So use that relation to find out T1, shearing strength of spigot end. So in that A is unknown. Use that relation to find out A. Then tensile strength of socket through quarter hole. So in that you have D1 and D2. So T. So you can determine D1 using that relation. Similarly, you have equation G. In that D4 minus D2 into T into sigma C. That is the equation. From that equation, you can find out D4. Then shearing strength of the socket collar, P is equal to 2C into D4 minus D2 into tau. In that C is unknown, so you can calculate C. Similarly, shearing strength of quarter pin, which is given as P is equal to 2 into B into T into tau. Using that, you can find out B value. Then crushing strength of quarter pin, so which is P is equal to D2 into T1 into sigma C. So you can find out T1 also using that relation. Okay, so that is what you have to do. So whatever order he has given in the data book, you follow the same data book. I don't know how many of you are following this also. I am reading all these things. I think most of you don't have data book also. I know that, but still, from my side, I have to teach all these things. That's why I am telling you. Whether you are learning it or you are using it, doesn't matter to me. If you use it, it is useful to you, or you can solve the problem in the examination. Because most of you are not able to attempt the first mid examination is successfully. So you got very poor marks. Our total is 64 members. 42 members are got less than 50% marks. 42 or 44, I think. I don't remember that correctly. So I don't know how we are going to improve in the examination also. I am telling all these things, but you are not at all. So most of you are even not attending the class also. You don't know how to use the data book also. Then how you are going to pass in the examination? That is up to you. Whether you are really willing to study or pass the examination, then only I can help you. So నేను చదవను, నాకు సంబంధం లేదు, నాకు డేటా బుక్ అక్కర్లేదు, లేదా డేటా బుక్ తెచ్చుకుంటారంటే మాకు షాపుల్లో లేవు, అది లేవు, ఇవన్నీ ఈ కబుర్లు అని చెప్పారంటే నేను చేయగలిగింది లేదు దానికి. మీరేమైనా నేర్చుకుంటాను, ఏదైనా ఉంది సార్ నాకు ఏమైనా చెప్పండి అంటే ఐ కెన్ హెల్ప్ యూ. అట్లా కాకుండా నాకు సంబంధం లేదులే, నేను ఏదో చేస్తాను, ఏదో పాస్ అవుతాను, ఏదో రాగం చేస్తాను అంటే దట్ ఈజ్ అప్ టు యూ, మీకే ఉంటుంది. సో స్టిల్ మీ దగ్గర డేటా బుక్ లేదని తెలిసినా కూడా నేను ఎందుకు చెప్తున్నా అంటే జస్ట్ అట్లీస్ట్ సంబడి విల్ లెర్న్ ఫ్రమ్ దిస్. ఇంకా అప్పుడన్నా డేటా బుక్ కొనుక్కుందారా బాబు అని ఏమన్నా ఒక్కడికన్నా వెళ్ళాల్సి వస్తే సో నా ఎఫర్ట్ సక్సెస్ అయినట్టే. See how many of you will do that. I think you are not at all inclined to buy the data book. సో ఎగ్జామ్ టైంలో వాళ్ళు ఇస్తారు కదా, మనం ఎందుకు డేటా బుక్ కొనుక్కోవాలనే ఉద్దేశంతో ఉన్నారు మీరు మోస్ట్ ఆఫ్ ది థింగ్స్. సో ఏదో ఎంతో కోట్లు లక్షలు సేవ్ చేస్తున్నారు డేటా బుక్ కొనుక్కోకుండా, అలా ఫీల్ అవుతారు మీరు. 1 కోటి రూపాయలు సేవ్ చేసినట్టు ఫీల్ అవుతారు ఒక డేటా బుక్ కొంటూ మానేస్తే. ఇంకో విషయం ఏంటంటే డేటా బుక్ కొనమనుకో, దాన్ని కొంటే ఒక 1 కోటి రూపాయలు ఖర్చు పెట్టాలి డేటా బుక్ కొనాలంటే. ఓకే, ఏదో ఖర్చు పెట్టి కొన్నాం అనుకో, కొన్న తర్వాత దాన్ని చూడాలి, చదవాలి, ఇదంతా నేర్చుకోవాలని. ఇంత పద్ధతి అయితే మరి మిమ్మల్ని ఎవడేం బాగు చేయలేడు. మోస్ట్ యూజ్లెస్ ఫెలోస్ ఉన్న ఈక్వేషన్స్ రాసి డేటా సింపుల్ ప్రాబ్లమ్స్ ఇచ్చారు సార్ ఎగ్జామినేషన్లో. ఆ సింపుల్ ప్రాబ్లమ్స్ కూడా సాల్వ్ చేయకుండా క్వశ్చన్ నెంబర్లు కూడా వేయకుండా ఇచ్చారు చాలా మంది పేపర్లు. 3 క్వశ్చన్లు ఉంటే 3 క్వశ్చన్లు అటెండ్ చేసిన వాళ్ళు కూడా లేరు ఎగ్జామ్లో. ఈ లెక్కన మీరు ఎగ్జామ్ ఎక్కడ పాస్ అవుతారో నాకు అర్థం కాదు. ఇంత యూజ్లెస్ ఫెలోస్ నేను ఎక్కడ చూడలేదు మిమ్మల్ని. సో అంటే అలవాటు పడిపోయారు అనమాట. ఎట్లాగో మనకి ఇప్పుడు దాకా 3-4 సబ్జెక్టులు ఉంటే బ్యాక్లాగ్లు, 3కి ఇంకోటి యాడ్ అవుతుంది, ఏమైతే లేదు, 4 యాడ్ అయితే ఏమైనా అన్న తరహాలో మీరు మీ పరిస్థితి అలా ఉంది. దానికి తోడు ఈ ఆన్లైన్ క్లాసులకు వచ్చినాక మీ ఇష్టారాజ్యం అయిపోయింది. మీ ఇష్టం వస్తే క్లాస్కి అటెండ్ అవ్వచ్చు, మీ ఇష్టం కాకపోతే వదిలేయచ్చు. మిమ్మల్ని అడిగేవాడే వదిలేడు కదా. సరే, ఇఫ్ యు ఆర్ డూయింగ్ లైక్ దట్, సో దానివల్ల వచ్చే లాస్ మీకే వస్తుంది, నాకే రాదు. సో నువ్వు చదివితే నువ్వే పాస్ అవుతావు, చదవకపోతే నువ్వే ఫెయిల్ అవుతావు. నువ్వు పాస్ అవ్వకుండా నీకు ఎవడైతే డిగ్రీ ఇవ్వడు. నీకు డిగ్రీ కావాలంటే నువ్వు చదవాల్సిందే, పాస్ అవ్వాల్సిందే. పాస్ అయితేనే నీకు డిగ్రీ. ఇంత ముందులాగా ఏదో కొన్ని సబ్జెక్టులు వదిలేసుకుంటే డిగ్రీ వస్తుంది అనుకోవద్దు. అన్ని సబ్జెక్టులు పాస్ అయితేనే మీకు డిగ్రీ వస్తుంది. ఓకే, రైట్. సో దెన్ వాట్ విల్ డూ is we'll take up one numerical problem on that also. So then we'll try to solve this. So using the procedure what we did. So now use the data book to solve this problem. Also you have to use the data book. That is the thing here you need to consider. So now the problem is design a counter joint to connect piston rod to the crosshead of a double acting steam engine. The diameter of the cylinder is 300 mm and the steam pressure is 1 Newton per mm square. The allowable stress of the material for the counter and piston rods are as follows. Sigma T is 50 MPa, tau is 40 MPa and sigma C is 84 MPa. So this is the given problem. Like already told, in the problem they will give P value. Sometimes they may or may not give the sigma T, tau and sigma C values. But in this problem, he has given the sigma T, tau and sigma C values directly. But that load, tensile load is he has given indirectly. So what he has given is, he has given the application of the counter joint. The counter joint is used to connect the piston rod and crosshead. So for that, so we have a cylinder which is having a diameter of 300 mm and the steam pressure he has given. So therefore, if you use the steam pressure multiplied by the area which is upon which this pressure is acting, you will get the load, tensile load. So that is nothing but 5/4 d square, where capital D will use capital D here, because don't confuse between the small d and capital D. We already used the small d for the diameter of the rod. So here capital D will use for the diameter of the cylinder, that is 300. So therefore 5/4 capital D square is going to be the area of the cylinder multiplied by the pressure. We get the what is the axial load on this counter joint. So once you got that, then that means you know P value, sigma T, tau and sigma C is given. So then use the data book, use the formulas accordingly and try to find out what are the various parameters for the counter joint. So here, but here I selected a different joint. So now you can see that here earlier discussion what we have discussed there, that is different figure diagram. You can refer here. This is a different diagram and that is a different diagram, but it is quite similar, but still we can't these two are equal. That means the number of dimensions here you need to calculate is small when compared to the previous one. So here you have to calculate only D, D1, D2, D3, B and T. So for this also the formulas are you will get from the data book only. Whatever we taken that socket and spigot joint, there what is the diameter D formula, you have to use the same formula only. D1, D2, D3. So whatever formulas are there in our data book, you have to use only those formulas. Because here the parameters are all same. Parameters are same, so therefore you have to use only same formulas. But only thing is here you can see the figure, it is somewhat different. That is the only thing. So here what is D2? D2 is the outside diameter of the rod. So here also diameter of the piston rod. So D2 and D is diameter of the rod. Here where is it? This is the diameter of the rod D. D1 is diameter of taper end of the piston. So this is the D1. Then what is D2 here? D2 is D3 is this one outside diameter of the socket. Then B is the width of the cotter and T is the thickness of the cotter. So the same thing is there, but only thing is here the diagram is look like somewhat different. But don't okay, so don't confuse that whatever their cotter joint, socket and spigot joint is there in your data book, that is not same as this one. Even though it is different, but the formulas, all these things, what you are going to use is same. So use those formulas to find the solution for that problem. So now see here, you can see that first we calculated what is the load. Load is nothing but 5/4 into d square into pressure. That comes out as 70,695 newtons. Then first, okay, so directly is the, okay, why he has calculated directly D2 value. Maybe it is missing. Okay, D is calculated using empirical relations. Okay, no problem. So the diameter of the piston rod at the center, D2. So this is the formula what we used in earlier also. 5/4 dt square minus D2 into T only. So if you refer the data book, that formula is there with you. So to compute the data 7, if you open that page again, so formula B is there. So that is nothing but tensile strength of spigot through cotter hole. Here also the same thing. In place of that, only what you have is, in case of spigot you have a piston rod. In case of socket, you have a cylindrical crosshead. That is the only thing here. So this is using this relation, you can find out D2. And see here, this assumption is also there. So D2 into T he has taken. So this T, thickness of the cover, he has taken 0.3 times D2 only. So that is also there in our data book. T is equal to 0.3 times D. So then using these relations, he calculated what is D2 and what is 3. Then width of the cotter means you need to consider what is the double shearing strength of the cotter, 2B into T into tau. So that should be equal to your applied load P. So from that you will get P value. Then diameter of the outside diameter, this D3 is the outside diameter. So this is the formula what you use. You can see that formula is also there. Tensile strength of the socket through cotter hole. So if you look at that, this is the formula. So in that D2 is already calculated. Using this you can calculate D3 value. But only problem here it is, you will get a quadratic equation for D3. If you solve the quadratic equation, you will get two values. So one is positive, other one is negative. Since you don't have a negative dimension, you have to consider only the positive dimension. So that comes out as 72 here. Then after that, you need to check for the crushing strength. So here crushing strength, if you use that formula, you got it as 252 MPa, and this is greater than the permissible value of 84. See, like already told, once you determine the dimensions, you need to check for the crushing stress. See here, the allowable crushing stress value is only 84. So in the given data, the problem data, he has given sigma C is 84 MPa only. But with the dimension of D3, whatever he calculated here, the D3 is 72 mm and T is calculated here 16.5 mm. So with those dimensions, sigma C comes out as 252 MPa. So this 252 is more than 84, therefore these dimensions are not correct. So therefore, then D3 is calculated based on the sigma C. Sigma C is taken as 84 now. The same thing equation is used here. From that you can calculate D3. D3 comes out as 106 mm. So that means with the D3 72 it is going to fail. If you need to take D3 as 106 mm. So these are then empirical relations. L, length of the cotter. So L is nothing but same thing. All these things are available in that data book only. You can use those relations to find out these dimensions. Okay. So now what I do is I will provide this one to note it down. So first you note down this problem and then note down this figure and then try to use the data book and try to solve this problem on your own so that it will be more beneficial to you. So I think 10 more minutes time is there. Within the 10 minutes you try to do it, or else even at the end of the class, I think this is the second hour only. So after at the end of the third hour, you can after that also you can try to complete and you can upload the solution in the class. So, but if you upload the class solution for this problem, then only I will give you the attendance. Otherwise, I won't give you the attendance. I will verify all your whatever you uploaded there in the class. Now I will verify all your documents. Then, if you uploaded the solution for this one only, I will provide you the attendance. Okay. So note it down this problem and then try to solve this. So for this, solving this, you have all the formulas are there in our data book except this D1. So here D1 you can easily calculate using the tapper. You can easily calculate this D1 also. Anyway, so you try to do that. I'll check it. Or else if you have any doubt, then you can ask it. No issue. So if you have any doubt or clarification, I'll explain. I'll explain to you. Then you can solve it.
సార్
Tell me.
సార్ అది D2 కనుక్కునేటప్పుడు D2 కి T కి రిలేషన్ తీసుకోవాలా సార్?
You have to take that relation.
అది రిలేషన్ ఏంటి సార్ ఒకసారి చెప్తారా?
D2 is equal to or T equal to D2 by 4 రా.
T is equal to D2/4. ఓకే
నీ
సార్.
దగ్గర డేటా బుక్ లేదు నీ దగ్గర?
ఉంది సార్, ఉంది సార్.
డేటా బుక్ ఇచ్చాడు కదా, చూడు ఒకసారి ఓపెన్ చేయాలి.
ఎస్ సార్.
నేను చెప్తే మళ్ళీ నువ్వు మర్చిపోతావు, మళ్ళీ గుర్తుండదు కదా నీకు. ఒకసారి డేటా బుక్ లో చూస్తే చాప్టర్ నెంబర్ 7 ఏది నీకు సాఫ్ట్ కాపీ
చాప్టర్ నెంబర్ 8 సార్ దీంట్లో. చాప్టర్ నెంబర్ 8 సార్ దీంట్లో.
8 చాప్టర్ నెంబర్ 8 లో నీకు ఫస్ట్ ఉంది కదా, కార్డర్ జాయింట్ ఫిగర్ ఉందా, సాకెట్ అండ్ స్పైగట్ జాయింట్ ఫిగర్ ఉంది కదా, దాంట్లో ఈక్వేషన్ ఇచ్చాడా?
ఎస్ సార్, ఇచ్చారు సార్.
ఈక్వేషన్స్ తర్వాత కింద ఇచ్చాడు చూడు, యూజువల్ ప్రపోర్షన్స్ ఆఫ్ సాకెట్ అండ్ స్పైగట్ కార్డర్ జాయింట్ అని ఇచ్చాడా?
ఎస్ సార్.
సో దాంట్లో ఏమి ఇచ్చాడు నీకు? T is equal to 0.3D అని ఉందా?
0.25D సార్. 0.25 D2.
అంతే కదా?
0.25 D2 ఉంది సార్. అవును సార్.
అంటే అంటే D2/4 ఏగా 0.25 D2 అంటే.
ఎస్ సార్.
యూజ్ దట్ రిలేషన్.
ఓకే సార్, థ్యాంక్ యూ సార్.
ఓకే.
D2 is equal to 51.4 mm వస్తుంది సార్.
ఎంత
51.4 వస్తుంది సార్.
D2నా
ఎస్ సార్.
51.4
ఎస్ సార్.
P ఎంతరా నీకు వచ్చింది? 70695 వచ్చిందా?
ఎస్ సార్.
దాన్ని ఈక్వేట్ చేస్తే ఇడికి ఎంత వచ్చింది? 53.97 వచ్చింది ఇడికి. ఓకే 51 పాయింట్ సంథింగ్ వచ్చిందా?
ఎస్ సార్.
ఓకే రౌండ్ ఇట్ ఆఫ్ టు నెక్స్ట్ నెంబర్. సో 51 అంటే 52కి రౌండ్ చేసుకో. ఇటు 55 తీసుకోండి. నో ఇష్యూ. ఆ వేరియేషన్ ఓకే వెలడ్. హలో ఎవరండి? నాట్ రిక్వైర్డ్.